One of the nice things about running a YouTube channel is all of the interesting questions and thoughts that you send my way. Sometimes they're one-liners that help me think about the world differently, and sometimes they're in-depth questions that I just have to make a video about. And this week I got a really interesting question from Doug, who also supports this channel on Patreon. Thanks, Doug. Asking why automakers generally don't let customers use all of the available capacity in their electric car's battery pack. He writes, "My car right now is a Chevy Volt 2013 and I'm looking, with the blessings of my wife, for a Chevy Bolt 2018. Since owning the Volt and soon to be the Bolt, I've had the same thing turn up in my mind, which is why GM doesn't open up the full battery. I have a darndest time looking for the documentation on this, but I know the software limit for the amount of battery to be about 80 to 70%. The limitation is great for the battery. Lithium batteries love to be at that range, but the battery can be pushed every now and then, as Tesla has shown, to 100% for rare long drives. Does GM not trust the user and believe they will be sued and/or have to give new batteries to buyers like Nissan once someone abuses the battery? To be clear, I'm not asking for the 100% all the time. Just make a mode in the software that allows 100% for a few drives with a big red screen with a warning about what can happen to the battery if it's used too much." Doug, thanks for the great question. While I'm not available to speak to individual automakers, I can speak to the engineering side of things. But before I do, let's do a quick recap for those who aren't aware of how automotive lithium-ion traction batteries are treated. As Doug mentioned, lithium-ion batteries do prefer to operate in a battery region between about 20% and 80% capacity, actual capacity. And that means the battery capacity you see on your car's state of charge display isn't actually representative of the total real capacity of your car's battery pack. It's the safe range as determined by your car's maker. So when your car says it's empty, it's still got a little in reserve. You can't use it though, because using extremes of charge, be they upper or lower, can cause your car's battery to age prematurely. Now to Tesla. It used to have something called range mode, which allowed you to charge the battery a little more than usual, about 90% actual capacity, and drain the battery a little more than usual. And when you engaged this mode, it gave you a warning about battery life being shortened by using it too much. These days, it seems range mode is slightly different because the latest version of the Tesla operating system gives you a warning about reduced cabin heat instead and doesn't mention anything about battery life. You can still adjust where the car charges to. It now uses a day range and a trip range when talking about charging, but nevertheless, Doug's question is still valid. Why don't automakers let you push the limits of your car's battery when Tesla, certainly at one time, does or did? The answer, I think, and I should emphasize I think, here lies in the way that Tesla's battery works versus the way that other battery packs in EVs work. Tesla's Model S and Model X battery pack uses thousands of tiny 18650 batteries, which individually don't have a massive capacity, arranged in parallel to form bricks. Those bricks are then connected in series to provide the correct voltage for the Tesla to use. They also, when combined, have a massive energy capacity and extremely stable voltage, but I'll come on to that in a second. The Nissan Leaf and other electric cars also use parallel cells mated together and then arranged in series, but rather than have lots and lots of tiny battery cells arranged together in parallel and then in series, the battery modules inside most other electric cars usually have a couple of pairs of much larger capacity cells arranged in parallel, which are then connected in series with another set inside a battery module. The modules are then connected in series with one another to produce the correct voltage required by the car. In other words, there are less battery cells connected in parallel in most car battery packs than you'd find in a Tesla battery pack. Why is this important? Well, lithium-ion battery packs have a fairly linear charge and discharge curve over the majority of their capacity. That means that the cell voltage rises gradually or drops gradually during charge and discharge. When they reach the top of their state of charge, the voltage rises very quickly for each remaining percent of charge you can cram in, and when you're at the bottom of their state of charge, the voltage drops very quickly. And it's generally accepted that when you go into that final bit of charge where the voltage drops very quickly, you can cause the cells some serious damage. And the more current, the more power you pull, the quicker the voltage drop and the more damage you can cause. If you've got lots of tiny battery cells all pushing electricity in a parallel circuit, the current being provided by those batteries is the sum of all of those batteries pushing together, meaning each battery is providing a fraction of the total current. And it's much harder to damage the batteries and push them into the danger zone because you're using less current, even if you're going below the usual state of charge. When a battery is in series, every battery is providing the same current, which stresses the battery cells out more and causes more damage if you're at a low state of charge. Essentially, when you draw a current from a battery pack made of large capacity cells, the voltage drop is greater than if you draw the same current from a battery pack made of small capacity cells arranged in parallel, even if the state of charge is the same. In other words, to answer why Tesla can do this but others can't, well, I think it's part engineering and part self-preservation for the automakers, because battery damage is more likely at a low state of charge in batteries made with large capacity cells arranged in series than it is to have smaller capacity cells arranged in parallel and then arranged in series. And automakers don't want to have to spend a lot of money or time on warranty claims. As to why some batteries are better and have less degradation than others, well, that's down to cooling practices or a lack of them, but it's also down to physical pack design and how carefully the car's onboard battery system babies the batteries. Volt battery packs have much less capacity loss than a comparable Leaf because General Motors makes less of the total battery capacity available to the car, and it liquid cools them. Nissan doesn't, and it uses more of the total capacity. That's it. As always, hit the notification bell to hear the moment a new show is uploaded. Subscribe to both of our channels, and if you fancy it, support us by using one of the 2 links below or by buying something from our shop. And a final reminder about our new giveaway on this channel to celebrate our impending 50,000th subscriber. We are still not there yet, but we are nearly there. We've partnered with Oscar and Hamish, who make tailored handmade luggage for your EV, to give Transport Evolved subscribers the chance to win a custom frunk set for a Tesla Model X or a Model S. If you'd like to buy one of your own, you can also get a 10% discount by using the code in the description below. To take part, follow Transport Evolved at Transport Evolve on Twitter and Oscar and Hamish on Instagram at Oscar Hamish, and tell us about the adventures you'd go on with a custom handmade set of Model S or Model X luggage in your car using the hashtag #EvolvedLuggage. We'll run the competition until we hit our 50,000th subscriber, so you've got a few days or maybe a week left to get your entry in. Thanks for watching, and as always, keep evolving!